question number 3 on the June 2013 AQA S1 paper. And we've got a binomial distribution question. So we've got items of jewellery for sale, and each has different prices. So we've got a table of probabilities that we need to use to answer this question. And it tells me, for example, the probability an item achieves at least its lower price estimate, but not the upper price estimate of 0.325. So you need to think about how they're working it out. So they're doing 0.5 take away 0.175. So really the hardest bit of this question is trying to work out which probability we need to use, because once we know that, we can just put it into our binomial. Here it's telling us that 40 items n equals 40. So we know that we've got a binomial distribution. So the outcome is distributed binomially, n is 40, and some probability that we need to take from this table or calculate. So use a binomial distribution to find the probability that most 10 items do not achieve their reserve price. Okay? So if it doesn't achieve its reserve price, we can see the probability of that is 0.15, so that's what we're going to use. So x is less than 10, less than or equal to 10. I'm just using x here because that's what I normally use. So probability x is less than or equal to 10. So at most 10 do not achieve the reserve price. So we can just use our table for that. So I'm going to look at my normal table, my binomial table. So when we're using the binomial tables, first we need to find the correct one. So here I've got n equals 40. We've got a different table for each different number of trials. Now our probability is 0.15. So I'm looking at this column here. And we're saying less than or equal to 10. So I'm going to go across on 10. This is my probability, 0.9701. So I'll just give that 970. Part 2, 25 or more items achieve at least their lowest price estimate. So at least their lower price estimate. So we need to think about what we're going to use here. So if we go up to our table, at least the lower price estimate is 0.5 probability. So p equals 0.5 in this case. I've used x for achieving the reserve price, so I need to use a different variable. So if we're looking at low price estimate, we can put LPE, or we can just put y. So I want at least the lower price estimate, so 25 or more items, y is greater or equal to 25, and at least the lower price estimate. So on my table I can only look up less than values, so I have to do 1 minus something. So 1 minus probability being y being less than or equal to 24. So obviously if I'm doing it straight on my calculator, I don't need to do that bit, but I'm going to use the table. So I've got my probability of 0.5 this time. So that one's here. And we want less than or equal to 24. So that's going to be this probability here, 0.9231. So go back here, 0.9321. And we want 1 minus that, 0.9321. So that's going to be an answer of 0.077. Okay, part 3. Exactly 2 items achieve at least their upper price estimates. So because we're doing exactly 2, we can just plug our values into the binomial equation. So I've got 40, n equals 40, and I want two of them. And I want them to achieve at least their upper price estimate. So if I go back to the table that I originally had, item achieves at least its upper price estimate, 0.175. So I want two of those, 0.175 to the power of 2. And then 1 minus that probability is 0. So I'm multiplying that, 8, 2, 5, and we need 38 of those. So these two numbers have to add up to 40. So I'm just going to work that one out straight away. That's going to give me 0.016. If I couldn't remember that binomial equation, I could look that up in the formula book as well. So that's part 3. And then part 4 for part A. More than 10 items, but fewer than 15 items achieve at least their reserve price, but not their lower price estimate. So there's a lot going on here. So firstly, I'm going to think about, well, what am I trying to work out? So I'm trying to work out more than 10, but fewer than 15. So this time, let's just say, what do we need? We were thinking about reserve price, so I'll give that R. So I want this probability that R is between these two values. So what is R? So R is at least the reserve price. So R is distributed binomially. 40 items. What is the probability? It's what I'm thinking about now. So at least the reserve price. So look at that, that's 0.85. But not the lower price estimate. So not this one here. So what's between those two? Well, if I took one away from the other, I'm going to get 0.35. So that's going to be what I'm going to use for this one. 0.85 take away 0.5, 0.35, that's the probability that I need to use in this case. So that's the first thing. Now I need to think about what do I actually need to look up on the table. So I want the probability that R is less than 15. So that's the same as R being less than or equal to 14. And then I want everything bigger than 10. So I need to take away the probability of R being less than or equal to 10. I don't want to include 10. Okay. So I've got my limits there. Now I can look up those two on the table. So for probability 0.35, find that on my table. This is the column I want. And I want less than or equal to 14, 0.5721. Take away less than or equal to 10, which is 0.1215. So that's the calculation that I need to do. 0.5721. Take away 0.1215, and that will give me my probability of 0.4506, and that's my answer for part 4. So now finally, part B. How many of the 40 items of jewellery would you expect to achieve at least their reserve price but not their upper price estimate? So if I want to find how many I would expect, then I need to do how many I've got times the probability. So that's how we work out what we would expect, the number times the probability. So what probability am I going to use this time? So this time I want at least the reserve price, 0.85, but not the upper price estimate. So I need to take away 0.175. That will give me my probability I need to use, which is 0.675. So I've got my probability, then I just need to multiply by 40. 40 times by 0.675. So I'm just doing NP here. And what do we get? Oh, so it's 27. There might be other ways to find this. This is the most straightforward.